All right, ladies and gentlemen, in this video, we are going to kind of mix together some geometry and some algebraic connections as a way to represent our theorem of the mid-segment theorem of a triangle. And so let's talk here for a sec. It says that in the following triangle, A, B, and C are midpoints. Stop. Why is that important? Because that means that AB, BC, and AC are all mid-segments. All three of them are mid-segments. So what do we know? We know that the mid-segments are half of its opposite side and they're parallel to its opposite side. So for example, we see here that AB is the mid-segment that is opposite of GJ. So AB is half of GJ. Well, this is great because we get two expressions, one for AB and one for GJ. So we know that means we can substitute what we know about these two expressions into the segments, and we can go ahead and use that to solve for x, and then ultimately substitute it back to solve for AB. So we see here that we have, in mind, you don't have to necessarily go this way, because I see even numbers everywhere, and inside the parentheses, I can just distribute into both of these, and I get 3x plus 8 equals x plus 12. Of course, you could have multiplied by 2 to get rid of the fraction on both sides, so it's up to you. I subtract the x, and I get 2x. I subtract the 8, and I get 4. So that means x after dividing is 2. But I want to know what AB actually is, and so AB ends up equaling 3 times 2 plus 8. 6 plus 8 ends up getting us 14. And so the value of AB is 14. But this is even greater because now I can use this in some context as well, that if I wanted to find what GJ was, I know that it would automatically have been 28 by multiplying it by 2. Or of course I could have substituted in there as well.